So how are you going to prove to me you are who you say you are, especially if you're remote and you're, for example, talking to me over the phone? This happened to me a couple of days ago. I had this message left on my machine. It said, "This is Agent Roberts of the Texas Department of Social Security. Your Social Security number is being used for money laundering by a drug cartel. Phone me at 303 da da da, etc." So I saw this in my messages and it kind of worried me. So I responded, "This is John Williams. You phoned me about my Social Security number. And what do you want me to do about it? I'm certainly not laundering any money." So he came back saying, "This is Agent Roberts. You need to answer some questions so I can help you. First, I need you to confirm that you're John Williams because I'm going to reveal to you personal information. So please tell me your date of birth and Social Security number." So this kind of worried me. So I responded to him, "So how do I know you're actually a federal agent and that you're working for the government?" And he said, "Well, my name is Agent Roberts and my government number is 7453913 and I'm based in Texas Social Security Office. I can hand you to my boss if you like." And I said, "Well, no, I mean, if you're not who you say you are, how do I know your boss is who he says he is? So I've no way to check any information that you give me over the phone." And he said, "Look, I'm trying to help you. You're in serious trouble. Money laundering is a federal offense, you know. I can send the cops and have you arrested. Do you want that?" I thought that was strange, him saying, "I can send the cops," rather than "I can send law enforcement" or something more formal. So I began to really worry that he wasn't who he said he was. So I said, "No, but since you phoned me, why don't you tell me my Social Security number? Since you say it's being laundered, you must have it." He said, "I can't reveal that private information until you prove who you are." So I said, "Look, we're at deadlock here. Neither of us can prove who we are. Why don't you send me a letter? That's how the IRS gets in touch with me." He said, "If you don't want my help, then I'm going to hang up, but you'll be sorry." And that was the end. And I thought to myself, how does validation work over the internet if we're kind of distant from people? And I looked up on the web, and certainly there are lots of Social Security scams. So I think this caller was a scammer. I haven't heard anything since, but it hasn't been that long. But it did get me to think about how would you verify online who somebody is. And so I started looking online and came across the fact that there's something called synthetic ID theft, where they don't steal your whole ID, they just put together pieces from different people to create a new person and get that person credit rating so that they can borrow money, and then one day they're gone and they don't pay the money back.
Synthetic ID is something hard to understand. It's a hybrid between a real person and fake data. So a lot of times synthetic ID is attributes that are associated to a real person, but you can't find them, you can't follow them, you can't trace them. So synthetic ID is hard because sometimes you just run out of options to connect to the real consumer, or you can't validate the data in a real way. So that's the challenge with synthetic ID. It isn't a new problem. It's actually a problem that will continue to manifest as long as consumers and users continue to try to use more and more means to interact with their merchants or with banks or financial institutions. So synthetic is a hard problem, but something that you have to look very holistically and look at every angle of opportunities to connect data and the dots and interact with the users the minimal that you need so that it's still convenient, but at the same point verified that it's a real user and their data matches to who you're engaging with.
So often what the crooks will do is they'll take the social security number from a child that isn't going to be using it for several years, and then they'll take the address from somewhere else and build up this credit history, if you like, and credit rating against this child's social security number. They then borrow money or get issued credit cards they have no intent to pay back what they borrow. And what they do, they call it a bust out, when they max out the cards, take as many loans as they can, and then they disappear. And then several years later, the child may find out they're going to college and they can't get college loans because their social security number has been associated with criminal activity. Now, the criminals already have a lot of data out there about people. Equifax were compromised and lost around 140 million records with social security numbers and other data. And so that combined with other breaches that have been going on, there are several hundred millions of users' information out there that can be combined together to form these synthetic IDs. And it's not only synthetic IDs, there are lots of scams out there where they call them tech support scams, where they're saying they'll help you clean your computer, make your computer go faster, or that you've possibly got viruses on them that need to be cleaned up. And Microsoft get around 10,000 calls a month associated with these scamming calls. Typical one would be that they say that you're detected a virus and on your machine and that you need to call this number to clean it up, and of course they're going to charge you money and scam you. So these are standard calls. Now, our traditional way of proving our identity is with paper documents such as a passport or with a credit card or with an identification card of some kind. But I got around to thinking after this brush with Agent Roberts in Texas and the money laundering that was being used by the drug lords, is there any way to verify somebody's identity online? And there's lots of business cases for this. For example, you'd like to engage with your customer as painlessly as possible. You don't want them to have to send you lots of documents. And so companies are approaching this problem, looking at whether you can just send them, for example, photographs of your documents, or they can verify those against other databases that they have. So this company actually does ID document verification online, where you take a photograph of your driver's license or ID card and they'll verify the contents against various databases. And the things that they check, they'll check things like the checksums on the numbers that appear on your license or on your document. They might test the blurriness of the photograph and the way that you captured it, and other checks that would verify that it's an honest image, if you like, and that your data is coherent and also hasn't been falsified. They're using this to transform the customer onboarding experience, for example, for banks. So they'd like to do as much as possible online. If you do face-to-face, it's expensive. And so they want to do this with the least interference and demands on the customer. So they want to make it an easy onboarding experience and yet be able to verify that you are who you say you are. And so there's a real business case for online verification. And here's another company that does similar things. These do checks that you don't have any sanctions. This is typically, say, for a company that there are no ongoing sanctions against you for the kinds of trades that you're trying to do with this financial institution. And we have a company here in Boston called Votes. there are several companies now doing online voting, and they verify the user by asking for a photograph first of a driver's license. This is mainly for US, and they have an agreement with the Department of Motor Vehicles that issue these licenses that they can access the databases and get these photographs verified. And then they want to make sure that you are who you say you are, in the sense that you're a live person. So they ask you to turn your video on, and they ask you to nod your face. So first say to the left, turn your head to the left, turn it to the right, nod up, nod down. And they want to make sure that you're a real live person in front of that camera. And then they'll do facial identification against the photograph as well to make sure that the two are the same. And so they're using that check mainly for voters that are voting from abroad. And so the idea of using a device like a cell phone to authenticate somebody is becoming a more widespread practice. And here we've got a case.
All right, so first I'm going to launch the application, and it's going to prompt me for my PIN or fingerprint. I like to use fingerprint access because it's much easier. And then you'll see my digital driver's license is now displayed. So it has a lot of the same information as a physical license, kind of maintains the look and feel. You can see the front and back of the license. But when you actually want to perform a verification, there's some options on there that you will select. So I'm going to hit that three-dot icon, and you'll see that it's launching three options here: law enforcement, proof of age, and TSA checkpoint. And the reason why there's three different verification options is because you're stair-stepping the amount of information you're giving. So if I'm proving my age, all I'm sharing is the fact that I'm over 21 or over 18 and what I look like, so they can make a visual comparison. For law enforcement, which is the application that we're showing here, this is an example of what would be in the police officer's cruiser. I'm going to hit this law enforcement button, and you'll see it's going to launch my camera, just my normal phone camera. The law enforcement officer would present me with this badge, which has a QR code on it. I'm just going to scan that, and you can see right there it's saying, now that it's scanned, do you consent to share your information with the law enforcement officer? I'm going to click OK, and then you can see it says transferring data. And almost immediately it appears on what would be in the police officer's vehicle. And you can see it pulls up my photo, a quick green indicator to say that it's valid. It also includes obviously all of my information that the officer may need to know, like my address, my age, my date of birth, things like that.
Now, we're all familiar with computer authorizations and identification. When we log in, we usually have a username and password. And if we have two-factor authentication, it's going to send a message possibly to our device, and we have to look at our cell phone, pick out the numbers, and then type them into the browser. And so it's usually when we're doing computing, we have users, so that's we know who the person is with the identity. And the user has certain permissions associated with them. And in this case, we're showing here the typical ACLs, so-called, for access to files. And this user has certain read, write, or execute permissions. And so typically we have users with permissions. They tend to be fixed. They don't tend to be that dynamic. Or in the case of where we're using, say, our laptop, that we may be the super user and we have all kinds of permissions. But in general, you should operate always with the lowest set of permissions that you can. So even if you are the super user, you should log in as another user with lesser permissions. And it becomes more complicated when we have not only users, but that we have devices and applications that they themselves may need permissions. So, for example, if we're in the cloud, we may have a pipeline that is automatically provisioning machines. So it may be spinning up new machines, and it may be putting software onto those machines. So we need another concept, And that Amazon uses the concept of roles. So this hat here indicates that this user, so the key indicates the users, may have certain roles. Now, it may not only be a user that has roles, but a machine may have roles. So we can put, say, an EC2 instance into the role of being able to spin up other EC2 instances and provision them. So this would be typical of continuous integration, continuous deployment pipeline, for example. But it makes things a lot more complicated. And we'll come back and probably talk in greater detail about these kinds of roles that Amazon uses. And so typically a role depends on trust. Who can assume this role? So depending on who you are, you may or may not be allowed to have that role. And then if you're in that role, what can you do after assuming that role? So depending on who you are, what your permission level might be within that role may alter. And so it's a much more tricky situation online than we've been talking about before, where we've just been looking at a simple identity and usually fixed permissions. Now here in a blockchain, your identity is determined by your private key and your public key. Here I've called the public key your address, because you give that away to other people. You give your address so they can send you money, but you never show your private key. So this is a fake private key. Don't try it on Ethereum. It won't get you very far. But you should never allow anyone to photograph your private key. Don't actually record it like I'm recording it here, because your private key is your account. If I have your private key, I am you, and I can take all your money. So you should become familiar with the PKI infrastructure. That's the public key infrastructure, which is this private and public keys. And so never share your private key with anyone, because that is your identity. They can impersonate you, and they can do all the things that they shouldn't be doing. And so don't allow people to photograph you when you're in front of your computer, because inadvertently they might be able to video you typing in your password or photograph one of your private keys. So be very careful with your keys. Okay, that's all for now.